All right, in this video we're going to be taking a little bit more deeper dive into what you saw in the last Edpuzzle video, which is something called confidence intervals. So as that video explained, a confidence interval is basically an interval of values in which we can be like 95% or 90% or 99% confident that a given sample mean will fall within that interval. So it kind of gives us a range of values where we can be really confident that the actual true mean would be inside that interval. So in this video, we're going to talk more about the computation, how you actually come up with that confidence interval. In Edpuzzle, I talked more about the interpretation of it, where it comes from, and this is going to be the computation, so the formula. In this Delta Math, all the problems are going to be 95% confidence intervals. So it's going to be a very similar process, but in the next video, we'll actually see where we could have 90% confidence intervals or 99%, or you could really even do like 85%. You could do any amount of confidence level that you want. We base that on the z-scores. So here's our formula for confidence intervals. Looks like this. X bar plus or minus z times s over the square root of n. So make sure you write this down. This is what we're going to be using for all of our confidence interval problems. And let's briefly talk about what all of these different variables mean. So x bar we've seen earlier in the year. That just represents the sample mean. We've been used to using the symbol mu a lot. That's the population mean. So same thing, it just refers to the population. So x bar refers to the sample mean. All right, and then we've got z. Z is going to represent a z-score for the confidence level. So this actually will change depending on our confidence level. The S, that stands for standard deviation of the sample. So again, for this one, we've been used to seeing the sigma. That's for the population. S represents the sample. So standard deviation of sample. And last, we have the N. N represents the sample size. So from the population, we're going to take a given sample size, calculate the mean. It's going to be given to us, right? And then we're going to calculate a confidence interval using these different things. So all of this is going to be known. We're going to use these to write our confidence intervals. So if we go ahead and just read through the first question, it says a study of a local high school tried to determine the mean amount of money that each student had saved. The survey studied a random sample of 77 students, so that is going to be our N in the high school, and found a mean savings of $3,400. So that's our mean. That's going to be x bar with a standard deviation of 1,100. That's going to be S. And we're doing a 95% confidence interval. So that's going to give us our Z. Now our Z is not going to be 95%. It actually corresponds to Z values using our table. And in the next video, I'll talk about where that actually comes from. For now, just know that we're going to use 1.96 for our Z. And it says that we're going to round all values to the nearest whole number. All right. So the nearest whole number is important here as well, because they actually even want us to round our Z values, which I'm not a big fan of, but we are going to be rounding everything to the nearest whole number. In reality, when you do these problems, like when we did them out of the book, I don't want you to do that. I would want you to leave Z as 1.96. However, it wants us to round all values, not just the final answer, all values to 1.96. So this is actually, we're just going to round that to 2. Okay, so let's go ahead and do a problem. Let's set it up here. So we're supposed to do x bar as our first one. So that was 3,400 plus or minus. And then we do our z. Now we're rounding the nearest whole number, so it's going to be 2. And then s was 1,100. So I'm going to do 1,100 over the square root of n, our sample size, which was 77. Just like that. And what I'm going to do is go ahead and just calculate this second part here on its own. So I'm just going to leave this as 3,400 plus or minus. I'm going to go ahead and do 2 parenthesis 1,100 divided by the square root of 77. And I get 250.71. And again, if this were a normal problem out of your textbook, I would want you to just leave it as 250.71. However, we're supposed to round all values, so even the intermediate steps, I found this out the hard way when I was just doing a problem or two, that you actually have to round all of the values, even these intermediate ones. So they actually want you to round that to the nearest whole number. So it actually will be 3,400 plus or minus 251, because I would round up to 251, right? So then what we're going to do is 3,400 plus 251 and 3,400 minus 251. And that's going to give us an interval of values. So if I do 3,400 minus 251, that gives me 3149, comma, and then 3,400 plus 251 gives me 3,651. All right, so what does this say? It says that we can be 95% confident that the mean falls within the interval 3,149 and 3,651, as in that's the amount of savings students have at a high school. So let's go ahead and type that in. All right. Let's go ahead and look at another one. Clear this out. So our formula is going to stay the same. And for the purposes of at least this delta math, you could actually even write this formula as x bar plus or minus. Our z is always, we're always going to be doing 95% confidence intervals for these problems. In reality, it does change, but we're just going to focus on the first one today. Since it's always going to be 95, you can actually go ahead and write this as 2 and then s over square root of n for all of these problems for these delta math ones. Just going to be x bar plus or minus 2 times s over the square root of n. So you could write that down when you're doing this. All right, so it says study was commissioned to find the mean weight of the residents in a certain town. The study examined a random sample of 113, so that's n. Found a mean weight of 198, so that's x bar, and a standard deviation of 29 pounds, that is s. Determine the 95% confidence interval for the mean, rounding all values to the nearest tenth. All right, so this is actually rounding to the nearest tenth. However, our z of 95%, it's still 1.96. When you round this to the nearest tenth, we would round it here, we'd look next door, and we would actually round that still to 2. So because it would, the 9 needs to go up, and that means it would make it 2. So we're still going to have 2 right there. All right, so let's go ahead and calculate this. We've got x bar first. X bar is 198 plus or minus 2 times s, which was 29, over the square root of 113. So we'll go ahead and do that second part of the calculation first. 2 times parenthesis 29 divided by the square root of 113. And we get 5.456. And again, we're rounding all values. So each intermediate value we have to round. So I should say that. So we actually want to round that to 5.5. Right. So it's going to be 198 plus and minus 5.5. And then so we'll do 198 minus 5.5. And we get 192.5. And then 198 plus 0.5, 5.5, sorry. And we get 203.5. One of the confusing things can be rounding all of the values as you go. I don't really know why they have you do that, but for whatever reason, that's the case on this. Rounding all of the intermediate values. And then let's go ahead and type that in. 192.5, 203.5, All right, let's go ahead and do one more. See if we get. All right, this one is on mean SAT scores. And I was going to start by identifying what we're going to be rounding to, all values to the nearest tenth. So we are doing 95%. As always, our z is 1.96. But again, when you round that to nearest tenth, it will equal 2. All right. So a study by the Department of Education in a certain state was trying to determine the mean SAT scores for graduating high school seniors. The study examined the scores of a random sample of 41. So that's our sample n. Graduating seniors and found the mean score to be 456. So that's our x bar. Standard deviation 108, that is s. So we're going to do x bar, 456, plus or minus 2 is our z-score, times s, which is 108. Just make sure you don't flip the s and the n. It's easy to do that. Make sure you get the n on the bottom. It's the square root of 41 on the bottom. All right, and then go ahead and do our 2 parentheses 108 divided by the square root of 41. And we get 33.73, so it's just going to be 33.7 because we're rounding all values to the nearest tenth. And then we do 456 minus 33.7 to get 422.3, and then 456 plus 33.7 to give us 489.7. And that will be our answer. So all of these Delta Math problems are very similar to this. Hopefully shouldn't be too confusing. As we do some book problems in the next section, those will get a little bit more challenging. But this will be a good foundation of the process we're doing here, identifying x bar, s, and n, and then basically plugging it in, adding and subtracting it. So let me know if you still do have questions, and good luck.